All right, let's take a look at the Chapter 10 review sheet, so you guys will be super prepared for the test. For the first three problems, they want us to find the value of x and then classify the triangle. So they're giving us the three angle measures. Now I have the answer written in here. You'll see they're written in. It's a little tilted because that's how it came through the copy machine, but we're focusing on the actual problem. Now they're giving us the three angles, and we know that there's 180 degrees in a triangle. So what we're going to do is we're going to do 6x minus 6 plus 3x plus 4 plus 5x. We're going to set that equal to 180 because there's 180 degrees, and this represents each of the degrees as we see with the symbol. 6x, 3x plus 5x, that's going to give us 14x. Those are our like terms. And we have negative 6 and a positive 4. So that's negative 2 or minus 2. The parentheses here didn't mean anything because we have no numbers right outside the parentheses, and inside we can't combine them because they're not like terms. So I go ahead, solve the problem, add 2 to both sides. I get 14x is equal to 182. I am a loud calculator, so I'm going to divide both sides, the inverse operation, to get rid of that 14. 182 divided by 14 is 13. Okay, so that's what we found the value of x. X equals 13, as we see here. Now they also want us to classify the triangle, so that means I'm going to have to substitute 13 in for x in each of these angles. So I'm going to substitute 13 in here. 5 times 13, and that's going to give me 65. So this angle is 65 degrees. This is going to be 6 times 13, and then minus 6. Substituting 13 in for x, this one's going to be 72 degrees. And then here I'm going to do 3 times 13 plus 4. And that's going to tell me this is 43 degrees. So I look and I have a 65, 72, 43. They're all less than 90. It's an acute triangle. Okay? Let's try number 2. We have all of our angles given to us, so we're going to do it the same way we did the one right above. I'm going to add them all up, so it's 3x plus 10 plus x minus 4 plus 2x, and it's going to equal 180. Squeeze that in. Okay, so this is just my number 2. I look inside my parentheses and there are no like terms. I have no coefficients that need distributed in, so I'm going to go ahead then and just combine like terms. Basically what I have now is just an equation that looks like this. I took the parentheses away. It's exactly the same thing. The 3x, the x, and the 2x are all like terms. It's going to give me 6x. And the 10 and the negative 4 give me 6. Equals 180. I'm going to subtract 6 on both sides. 6x is equal to 174. The inverse operation is to divide by 6 on both sides. X then equals 29. So x is 29 degrees, and just like we did before, I have to substitute 29 in for x to find out what each of these angles are. So 2 times 29 is going to give me 58 degrees. 29 minus 4 is going to give me 25 degrees. And 3 times 29 plus 10 is going to give me 97 degrees. We have one that's greater than 90. That means it is an obtuse triangle. Okay? All right. I'm going to erase all that because I'm running out of room to do number 3 and continue on. Number 3 then, same concept. Okay, I'm going to do x plus 9 plus 2x plus 9 plus 4x minus 6. Ooh, whoopsies. I'll just squeeze that in down there. Equals 180. My parentheses here again don't mean anything, so if I want to rewrite it to make it less cluttered, I can. The reason I know that they don't mean anything is because there's no like terms inside the parentheses that need combined, and there's no numbers right outside that I can distribute in. X, 2x, and 4x are all like terms. That's going to give me 7x, and I have a 9, and a negative 6. So that's 18 minus 6 is going to give me 12, positive. And now I'm just ready to solve it. I'm going to subtract 12 on both sides. I get 7x is equal to 168. Divide by 7, x equals 24. Okay, I substitute 24 in for all of my x's. And when I do that, 24 plus 9, I get 33 degrees. I could do 2 times 24 plus 9. It's going to give me 57 degrees. And this is 4 times 29, I'm sorry, 24. 4 times 24 minus 6 is going to give me 90 degrees. So we have a right angle. And you can see that sometimes it's not as obvious, so don't just assume that it's a 90-degree angle unless you can actually substitute it and improve it, and then you can label it that way. Okay? Number 4, the perimeter of an equilateral triangle is 858 millimeters. Find the length of each side. So we have an equilateral triangle, we can draw it out. We know that each of our sides are going to be the same. They're talking about the perimeter. An equilateral refers to sides, so we know that they're each going to be x. The total is going to be 858, so I can say x plus x plus x equals 858. X are all like terms, so that's 3x. 3x equals 858. Divide by 3, x then equals 286. And this is millimeters. Okay? That's the length of each side for number 4. Number 5, the perimeter of an isosceles triangle is 162 feet. The length of one side is 60 feet. The length of the other two sides are equal. Find the lengths of the other two sides. So I'm going to draw out an isosceles triangle. Well, let's not go with that one. Let's sketch it again. An isosceles triangle has two sides that are exactly the same length. It kind of looks like an ice cream cone. Mine's obviously upside down. The perimeter, when I add up all the sides, is 162. The length of one side is 60. The length of the other two sides are equal. So these two sides are the same, so we can call those x. Now this one is 60, they're telling us, 60 feet. When we add up all of our sides, we should get 162, like they tell us. So I'm going to do that. X plus 60 equals 162. X and x are like terms, so I can add those. I'm going to subtract 60 on both sides. I get 2x is equal to 102. I'm going to divide by 2 on both sides, and I find that x is equal to 51, and these were feet. So x is 51 feet. And that's the answer we have here. So we're good. Okay, let's clear out our work again. Moving on, we're going to take a look now at number 6, I'm sorry. The ratio of the angle measures in a triangle is 8 to 9 to 19. Find the angle measures and then classify the triangle by its angle measures. So they're telling us the ratio is 8 to 9 to 19, and we're talking about angles here. So when we have a ratio like this, we can really say, like if I were to sketch out a random triangle, I don't know what it looks like, but I'm going to say that this angle is going to be 8x. This is going to be 9x, and this is going to be 19x. So all I do is really turn this into the same ratio, but I add in an x for each of our components. And that's because a ratio has to stay constant, and as long as we're multiplying everything by the same number, it remains that same ratio. So when you see a ratio, you can add in the value of x's. Now we're talking about the angle measures. So we know, like we did above, that all the angles total 180 degrees. So I can say 8x plus 9x plus 19x is going to equal 180, because that's how many degrees are in a triangle. 8x plus 9x plus 19 is going to give me 36x. They're all like terms. I'm going to divide both sides by 36. And x then equals 5. So we find that x is 5. Now they want us to find the angle measures, not just what x is. So like we did before, I'm going to substitute 5 in for x. So this is really 8 times 5, which is 40 degrees. This is 9 times 5, 45 degrees. And this is 19 times 5, which is 95 degrees. Okay, so we found each of our angles, and I have them listed here. Because one of them is greater than 90, it's an obtuse triangle. We're good. Okay? Let's move on to numbers 7, 8, and 9. On these ones, they're giving us polygons and quadrilaterals. This is from 10.2. They want us to find the value of x. Now, this is very similar to what we just did with triangles. The only difference here is that we have 4